Hi, and now we are on to lesson 3-3, which is going to cover even and odd functions. In this lesson, we are going to recognize even and odd functions given an equation or the graph, and we are going to distinguish between even and odd functions and even degree and odd degree functions. See that there's a difference between those things. All right, we are going to start with a couple of graphs, and then we're going to look at some symmetry on those graphs. So it says graph these two functions. So the first one's a quadratic. It's 3x squared plus 1. So if you remember, that means that the y-intercept is going to be up at 1. And the a value being 3 just means it's going to be a little bit skinnier of a quadratic. So you could make a table and plug in points, or you could use your graphing calculator, but you're going to end up getting a graph with like a little skinny u, and it looks like that, facing upward because the 3 is positive. Well, then we get to a graph that is a cubic, and so we kind of know the general shape of that the end behavior is opposite. The 2 is positive, which means it's going to start low, and then it's going to get high. And this particular one is going to be a little bit tighter, pulled a little tighter, so look a little bit like that. So that's the idea. It's going to cross right over at the origin. Okay, so what we want to do now is describe the symmetry for each graph. So if you look at the graph in number 1, you should notice that that graph has symmetry to the y-axis. So we would say it's symmetric to the y-axis. Okay, whereas the graph on number 3 is a little bit trickier to understand that kind of symmetry. There's something called symmetry to the origin, and that just means that when the graph rotates, prior to getting a 180-degree rotation, the graph will actually map to itself. So we're going to call this symmetry to the origin, or symmetric to the origin. Okay, and that's rotational symmetry. Okay, so that's going to be the basic shapes and the basic symmetry that happens with these kinds of graphs, and that we explain below. So it says the function, and then they give it to us as f of x equals 3x squared plus 1 is an even function. And what you want to notice is that every power of x is an even number. There is no x to the first term. There is kind of an x to the 0 power, and 0 is not usually considered even, but in this case it is. So 0 would be a constant, would be considered an even term. So this is true for the constant term as well, since you can write the constant as x to the 0. So symmetry of over the y-axis is an attribute of all even functions. So anything that was even would have some sort of symmetry over the y-axis. Okay, and then the other function, the cubic, well, that we call an odd function. Okay? And notice every power in the function is odd. We have x to the third, x to the first, there's no x squared, there's no x to the 0, there's no constant term. So symmetry around the origin is an attribute of all odd functions. Okay, now another way to look at even and odd is algebraically. So algebraically, you will see that an even function is one in which f of negative x produces f of x. So when you plug in a negative to an even power, it always comes back out to be positive. So the function doesn't change if you plug in a negative x, whereas in an odd function, it will always change. So an odd function is one in which f of negative x becomes negative f of x. Okay. Page 2. It says, examine the sketches we made in item 14 of the previous lesson. Use symmetry to determine which graphs are even and which are odd. All right, well, we have to go back to that lesson then. So item 14 of the previous lesson, if I flip back to that, let me go to attributes. And let's go back to, we'll go back to the number 14, where we made those 4 graphs. Nope, not those 2. We made the 6 graphs. There we go. All right, so if you notice, I already have them color-coded from the previous recording. And so you should be able to notice that A, B, E, and F are all even. They all have symmetry with the y-axis. And C, D, G, and H are odd. They all have origin or rotational symmetry. Okay. Okay, so now let's come out of there. Or do we need that one again? Let's see. Oh, yep. Let's go back to our current lesson. Okay, and we can fill that in. So our even functions were A, B, and then back down to E and F. Our odd functions were going to be C, D, G, and H. So the even functions have y-axis symmetry. And the odd functions have origin symmetry. So it says, explain how an examination of the equation in item 14 of the previous lesson supports your answer to item 4. Well, the even functions have only even powers. The even functions were like x to the fourth, or negative x to the fourth, x squared, negative x squared. And the odd functions did have only odd powers, like x cubed, x to the fifth, and so on. Okay, now what I want to do on this one is actually look at the two check your understanding questions. So on those two questions, it says explain why the function is neither even nor odd. So we didn't say that yet, but yeah, functions are either even, odd, or they could be neither. They don't have to have that symmetry. So if you look at the exponents, you're going to notice that it has x squared and x to the first. So the exponents, so I would say for number 6, 6 is going to be neither even nor odd, because we have both an x to the second and we have an x to the first. So in order to be even, you have to have all even exponents, or you have to have all odd exponents. But if you have a mixture like we do on number 6, then you have neither. Okay, let's look at number 7, because this kind of brings back yesterday's lesson. For a given polynomial, as x approaches negative infinity, the graph increases without bound. And as x approaches infinity, the graph decreases without bound. Is it possible that this graph is even? Well, let's just kind of get a little picture of that. So it says as x approaches infinity, negative infinity, we're increasing. Okay, so as x approaches negative infinity, we're increasing. So that looks like that. But as x approaches infinity, we're decreasing. It looks like that. So could that be an even function? We would say no. There is no symmetry to the y-axis. So there could be symmetry to the origin in this case. That would be odd if there was. So that was it, just a kind of a short little lesson today. So you have 3 problems to try, and that is all for your assignment. I will see you in class. Thanks, everyone.